Hello friends, I am Heena Khanna. Today I am going to explain the minimization of finite automata. So before minimization, I am assuming you all know what is finite automata. So suppose we have an example. This is the deterministic finite automata. Here I am explaining a few things. First, these are the Q0, Q1, Q2, Q3 and Q4. These are the various states. So in case of automata, we have a state set that is Q. It contains Q0, Q1, Q2, Q3 and Q4. Here, a state set is divided into two parts, final state and non-final state. Q0, Q1, Q2 and Q3, these are our non-final states and Q4 is our final state. And this arrow represent initial state. So here Q0 is initial state, Q4 is final state, Q1, Q2, Q3, they are non-final state. So second thing I would like to explain is del. Del is this transition function. And one thing more, A and B are input variables. These are input variables. Okay, so now I would explain what is del. This is Q, this is input and this is again Q. So what does it mean? When we apply any input variable to a state, then another state comes as output. Suppose now we are going to draw transition table from this diagram. So in case of transition table, we will see we have two input A and B. We have 5 state Q0, Q1, Q2, Q3 and Q4. This is our final state and this is our initial state. So when we apply input A to Q0, then output state is Q1. So output state is here Q1. When we apply B to Q0, then our output state is Q2. The same way, when we apply A to Q1, then output state is Q1. When we apply B to Q1, then output state is Q3. When we apply A to Q2, then output state is Q1. When we apply B to Q2, then output state is Q2. In the same way, in case of Q3, when we apply input A, then our output state is Q1. When we apply B to Q3, then our output state is Q4. In the same way, in case of Q4, when we apply input A to Q4, then our output state is Q1. When we apply B here, then our output state is Q2. So this is our transition table. Now we have to minimize it using partition method. So now we use this table to minimize our finite automata using partition method. In case of partition method, we will divide our states into two sets, final state set and non-final state set. So here we can see Q4 is our final state. So final state set will contain only Q4 and non-final state set contains Q0, Q1, Q2 and Q3. This is known as pi note. So pi note have two sets, Q4 and Q0, Q1, Q2 and Q3. This is our step 1. This is step 1. Now second step. In case of second step, we have to merge these states to minimize this automata. Okay, so final state set will remain same. There q pi 0 and this is pi 1. So this is q4. Now what will happen when we apply a to q naught, then answer is q1. When we apply a to q1, then answer is q1. Here q1, here also q1. So q1 lies in this set. Both are in the same set. So we can write q0 and q1. Fine. Now when we apply b to q0, the answer is q2. q2 is in this set. When we apply b to q1, then answer is q3. q3 also exists in this set. So these states can be merged. These states can be combined according to the current scenario. Now we will take another state q2. In case of q2, when we apply input A, then output state is q1. When we apply input B, then output state is q2. So q1, and we will see the relationship between q0 and q2. In case of q0, when we apply A, the output state is q1. In case of q2, when we apply A, the output state is q1. So q1 and q1 both lie in this set. Okay. In the same way, when we apply B to q0 and B to q2, output is q2. Both are in the same set. q2 and q2 both are in same set. So we can add q2 in this set. Okay. Now q3. In case of q3, when we apply input A, the output is q1. Fine. We are taking relationship between q0 and q3. And when we apply A to q0, the output is q1. You can see q0, input is A, output is q1. q3, input is A, output is q1. In the same way, q0, input is B, output is q2. And in case of q3, input is B, then output is q4. Now q1 and q1 both lie in this set. Fine. But q2 and q4, they are not lying in the same set. You can see q2 is in the set of non-final state and q4 in the set of final state. So we cannot merge this. So it means q0 and q3, we cannot combine these two states. Why we cannot combine? Because after the input, their output lies in the different state. So we separate q3 from there. So you can see now our output of second set is this. So our pi 1 is q4, q is one set, q0, q1, q2 is second set and q3 is another set. Now step 3, we will use this step pi 2. Okay, now first is q4, we cannot change this. Next set is our q3, we cannot change this. Now comes q0, q1 and q2. We have to find out relationship between q0, q1 and q2. So now you can see q0, when we apply input A, then output is q1. Next is q1. When we apply input A, output is q1. In case of q0, when we apply input B, output is q2. In case of q1, when we apply input B, output is q3. Now we will see the relation. q1 and q1 both lie in this set. Fine. q2 and q3, they are not lying in the same set. q2 and q3 are in the different set. So it means no relationship. Fine. Now we will see relationship between q0 and q2. When we apply input A, then output is q2. In case of Q2, when we apply Q1. In case of Q2, when we apply input A, output is Q1. So Q1 and Q1 both lie in the same set. Okay. Next, Q0, when we apply input B, output is, you can see, Q2. And in case of Q2, when we apply input B, output is Q2. So Q2 and Q2 both are in same set. So there is a relationship between Q0 and Q2. So fine. Now we will divide our Q0, Q2 and another set Q1. Fine. So now we have 4 sets, Q4, Q3, Q0, Q2 and Q1. Next step, step number 4. We will continue this step. Step number 4, pi 3. So first set is Q4, next is Q3, again Q1. Now you have to see relationship between Q0 and Q2. So Q0, when input is A, output is Q1. Q2, when input is A, output is Q1. Q1 and Q1 both lie in the same set. Fine. Next, Q0, input is B, output is Q2. Q2, input is B, output is Q2. So Q2 lie in the same set. So it means no need to separate these two states. Now you can see output of step 3 and output of step 4 both are same. Fine. It means this is the stopping condition. Fine. The stopping condition is when output of pi n is equal to pi n plus 1. So this is our stopping condition. Now what will we do to minimize this? Finally, we have 4 sets Q4, Q3, Q1 and Q0, Q2. Now what will we do? Come to the original deterministic finite automata. What we have to do? You have to combine these two states into a single state. Okay. Now what will you do? You can write Q4 as A, Q3 as B, Q1 as C and Q0, Q3 as D. Okay. This is our transition diagram. Again you have to draw this diagram. This is A, this is B. These are our input strings. In place of Q0 and Q2, you have to write D. Okay. Or you can write like this. Okay, first is our Q0. In place of Q0, you have to write like this, Q0, Q2. Fine. Q1 as it is. Q2. In place of Q2, you have to write Q0 and Q2. Next is our Q1. In place of Q1, Q1. Next Q1. Next is Q3. Next state is Q2. In place of Q2, you have to write Q0 and Q2. So Q0, Q2. Output is Q1. Q1 as it is. Then again Q2. In place of Q2, you have to write Q0 and Q2. Then Q3 as it is. Q1. In place of Q1, you have to write Q1. Again Q4. Q4. Q1. In place of Q2, you have to write Q0, Q2. From this set, we got what we have to do. In place of Q0, you have to replace Q0, Q2. In place of Q2, you have to replace Q0 and Q2. Fine. Now see Q0, Q2, Q1, or you can write like this. You have to change from Q2 to A, Q3 to B, Q1 to C, and Q0, Q2 to D. Again, one more table here. Input A, input B, Q0, Q2. What you have to write? D, our input state. Q1, in place of Q1 you have to write C. Q0, Q2. What do you have to write? D. Q1. Q1 is C. Q1. Again C. Q3. Q3 is B. Q0, Q2. That is D. Q1. Q1 is C. Again Q0, Q2. That is D. Q3. That is B. Q1. Q1 is C. Q4 is A. A is our final state. Okay. Q1, in place of Q1 you have to write C. Q0, Q2 you have to write D. Okay. This is our initial state and this is our final state. Now observe one thing. D, C, D. D, C, D. Okay. Both are same. So you have to write this only once. Okay. So from now we have transition table, this entry, this entry, this and this entry. Now draw finite automata with this transition table. What you have to do? Our initial state is D. We apply input A, C. When we apply input A, output is C. When we apply input B, output is B. Now C, input is, when input is A, then output state is C. So self loop. When we apply input B, then output is state B. Okay, this is not valid. Now B, when we apply input A to B, output is C. So this, when we apply B input, so output is A. A state is our final state. Double circle represent final state. When we apply input A to state A, output state is C. When we apply B input to state A, then output is D. So this is our initial state. This is our final state. Now total we have number of state is 4. But in case of our initial diagram, we have total number of state, that is 5. So you can see the difference. This is the minimization of this automata. So this is the minimization. So what is the use of minimization? Basically, main use of minimization is the reduction of time. I hope you enjoyed this video. If you have any doubt, then you can please comment. Thank you.